Tonight's talk, as I said, is this guy, me. As I said, I don't do talks for Code and Supply very often, but this is one talk that I'm really passionate about and really interested in bringing to all of you. I do a lot of documentation systems for work, and I've been handling documentation systems for a long time, so this is one that I'm really, really excited to share with you. So bear with me as I switch into presenter mode here. It's going to take me just a moment. Switch over to this camera and then share my screen. All right, cool. Looks like from my participant computer down below, you're able to see my presentation, and you will now be able to see my video. Great. We are in good shape. All right, so let's get started. Hi, I'm Colin Dean, as you may or may not have gathered by now. I'm generally wearing a top hat and scarf at conferences. I'm not wearing one right now because I can't wear a hat with this particular headset on. Otherwise, I would definitely be wearing one. It's also a little bit warm in my house, and scarves are warm, so it's probably not a good idea to wear it. Lawyers almost always say it's a good thing to say this, so I'm going to do it. The views expressed herein are my own and do not necessarily represent the views of my employers or associated organizations, past, present, and future. I work for Target. I'm based out of our tiny Pittsburgh office on Robotics Row in the Strip District. Like other tech workers, I'm working from home during the pandemic, so I am presenting this from my home in beautiful Wilkinsburg, Pennsylvania, just east of the city. I run Code and Supply. You may or may not have gathered that from now, based on me doing the broadcast. It's a Pittsburgh-based organization of more than 6,000 software professionals, and you're probably familiar with our co-working space that I talked about a little bit earlier, and our meetups and our conferences like Abstractions and Artifacts. I also am involved in MetaMesh. MetaMesh, since its beginning, is a bunch of 20-somethings trying to build a citywide mesh network here in Pittsburgh. In 2020, we've actually kind of starting to get there a little bit as we are pivoting to being a nonprofit wireless ISP. So do pay attention to the local news if you're in Pittsburgh, and you'll be seeing some really cool stuff coming out of us in the coming months. So to the real deal here. Our manager at Target came to us one day and told us that we were going to have an upcoming offsite, and we would be expected to present about the work that we've been doing at this offsite. A part of that necessitated a write-up detailing how our product worked at a high level. Multiple people would be consuming it. We knew that we needed a well-designed document that could be easily read when printed, but also take advantage of the various aspects of the hypermedia used to distribute it digitally. We'd most likely deliver a PDF, but a long web page wasn't off the table. We knew we needed to provide good content, but it needed to be well summarized and navigable. But then there was a big change. We had a development pause. Our product development was paused, so we needed to document everything. It may not be our team that continued development. With that development, our scope grew, and we had to go a lot more in depth to capture the knowledge of our team for posterity's sake. For example, what we'd originally intended to be a work on the depth, on the level of a quick tour of a house. It turned into being an owner's manual documenting every quirk and hidden compartment in that house. There are 7 of us, normally co-located. We each had different concerns and interests to be recorded in this document. The engineers needed to show how the product works, as well as how it's deployed as production software. The data scientists needed to show the business logic behind that software, including equations and citations with a veritable cornucopia of acronyms, initialisms, and other terms likely requiring a need for a glossary. We needed something that we could all easily use and something to which we could contribute simultaneously. After all, we just had a handful of days to complete this document. We needed a workflow that could get out of the way and let us focus on the content while still looking professional. It's a good practice to figure out some things that you value about a system before you start building it. When I'm building software as a software engineer, the initial idea, but somewhere after the initial idea comes, but before I start actually engineering a system for it, I think about quality attributes. We assumed that our content would be lots of text and diagrams and equations. We wanted a markup format that didn't require a special program to read. That is, we wanted it to be reviewable on GitHub. And we wanted to not be able to control styling within the document, except perhaps some semantic markers calling out special sections. We wanted to be able to use LaTeX if we needed it, because we knew that we might need to draw a diagram using TXE, one of the diagram packages for LaTeX, also sometimes just called TIKZ. Lastly, it needed to be easy to use for humans and computers. One command should build a document, and we should treat that document as a build artifact that is versioned and archived. The key idea is this. This concept of treating documentation as source code is probably not novel to folks who are seasoned documentarians, but for those for whom documentation is an afterthought, like many engineers and data scientists, this concept can be life-changing. These requirements basically eliminated Word and Pages and straight-up LaTeX, our internal Confluence wiki, and virtually every other less well-known text format. We considered some newfangled tools like MDBook, but found that they didn't have the quality of PDF output and integration with the niceties of the Pandoc ecosystem. We mostly wanted to avoid this. The team really already despised working in Word and wanted to actively avoid authoring anything in it, or authoring anything in our wiki system, which we would treat as ephemeral and quickly out of date. So we came up with a solution. We ended up building a solution based on this in about 2 weeks, while also writing prose. What this got us was simple text, easily read, reviewed, and agreed upon through our established systems of consensus, and produced the same way every time. It can even automatically notify stakeholders whenever we release a new version. But the biggest benefit, we were able to do LaTeX typesetting without suffering LaTeX. Our final document had very little raw LaTeX in it, outside of some equations and a couple of diagrams, which were simple enough to be quickly redone in TXE instead of leaving them as PNG or SVG images. But let's talk about Pandoc, a universal document converter. Pandoc was started a while ago and hit 1.0 in 2008. The 2.9.x release that we used came out just about as soon as we started doing the work on it. So that was October of 2019. Pandoc is written in Haskell, but it supports Lua for writing plugins that process an abstract syntax tree that Pandoc uses as an internal representation of the dozens of document formats that it can read and write. Let's talk about some Pandoc basics. Pandoc is available in virtually every package manager, and there are downloadable installers available on pandoc.org. Pandoc attempts to figure out what the input and output formats are based on the file names, but oftentimes it's better to be explicit. This is an example output of running Pandoc on an early version of these own slides, which is also written in Markdown and uses Pandoc to produce the code that comprises this presentation. Break down the chapters and sections into real separate files, and Pandoc will automatically concatenate the input. Note the use of filters here in this real invocation, and the choice of PDF engine that enables XeLaTeX or XeLaTeX, as some people call it, in order to use Unicode and some other implementation-specific features. Note the choices about the table of contents, section numbering, lists of figures, tables, and bibliography. I'll give you a moment to take a look at this while I have to get a drink. CLI metadata options can also be put into some YAML front matter in the document. Metadata and some other options can easily go into this YAML front matter, and Pandoc supports a configuration file containing all kinds of defaults. I started using this configuration file methodology in some newer projects in order to shorten the make file. I noticed that my make files were getting absolutely ridiculously huge whenever I was including all the options on that. As I said earlier, this presentation is written in Markdown, and Reveal and PowerPoint are supported as first class for output. In fact, I just, in the process of getting ready for tonight's talk, upgraded my build system for this from Reveal 392 to Reveal 402, which was necessitated by a newer version of Pandoc requiring Reveal 4.0, and Reveal 4.0 changing the entire layout of their distributable. So it was a fun 15 minutes of pulling my hair out while everything was on fire about an hour ago. Ultimately, you're going to need a build system. I like Make, and I found that any sufficiently advanced build script eventually simply re-implements Make. So you might as well just use Make. Gradle is another good option. There are some plugins out there that will make Gradle pull down Pandoc or use an existing Pandoc. Some common plugins. We've used Siteproc and Crossref extensively across virtually every product that every document that we've produced as a result of this. And then I've gone on and used this very same system to produce a workshop about plain text accounting. And I've used Siteproc and Crossref, as well as these other great plugins, especially Include Code, which pulls in files, and it's great for pulling in snippets from an external file that might change over time. I used PanPipe very extensively in my workshop. I could put code examples directly in the document and then write those examples to a file during the document build, and subsequent code blocks could execute the files that were written to disk. It was a really great way to effectively use Pandoc as a build system, and it worked out fantastically. These two together are absolutely fantastic for ever-changing data and source code, especially that's present in a moving target. If you're building documentation, building a presentation that would change with source code that changes within your application, you could put a system like this directly into your source code and be able to pull out living documentation. It ends up being a really high-quality product with that. There's lots of plugins out there for Pandoc. I strongly recommend using Lua plugins if you're going to write your own these days. A lot of things are written in Haskell, and when you write a Pandoc plugin in Haskell, it needs to be compiled. The Haskell compiler ecosystem is not small. It's not fast. So it's generally a better idea to write things in Lua if you can. There's also Python filters out there for those of you who like Python, but it does require a full Python installation. And I think they just added Python 3 support when 2.9 came out, Pandoc 2.9. Diagrams. Of course, you can't have a scientific document without something to show in terms of diagrams and equations. Images can be in a variety of format in Pandoc. I tend to convert everything to PDF and then include the PDF version in the Markdown, because I know that a PDF is going to look right 99% of the time versus SVG, primarily because SVG output rarely automatically converts fonts to paths. Also, if you have an SVG that looks right on somebody's computer, because they have a font installed, that font would need to be in the repository, and the user would need to know to install it in order to be able to render that SVG to PDF. So it's better off to just put the PDF in the repository. Here, the code example you're seeing on the bottom there, I redrew a diagram using Tixie, and it looked a whole lot better than the PDF that we derived from taking a screenshot of the original PDF from which we sourced the graph. Using the Pandoc Siteproc filter that I talked about earlier, we can easily enable bibliographical references. This is super important for when you're like writing a paper that you're intending to publish, but it's also really convenient when you're publishing something internally and you can see where you got all your information. You can actually have some citations and maintain your internal documentation with the same rigor that you would something you're going to publish. The next step in this, of course, is Git. Git was originally written to manage the Linux source code. Linus Torvalds himself wrote it, but it was really popularized in the late 2000s and early 2010s by none other than GitHub. GitHub is a widely used public website. I'm sure most of you are familiar with it. And it also has an on-premises version called GitHub Enterprise, something a little bit less well known. It's increasingly used by large companies. My employer, actually all of my previous employers included, except for my first job out of school in the mid 2000s. We've all used GitHub at some point. Next, I'll tell you about how my team used this powerful tool to create a workflow that enabled us to collaborate without having to pass around this silly Word file. We used 4 primary tools in this: Pandoc, GitHub, Git, and Drone CI. You can use any continuous integration system like Jenkins or Team Server or GitLab CI. In fact, Code and Supply is using GitLab in place of GitHub and GitLab CI in place of Drone as we produce our survey, compensation survey results document using this very same system. Those of you who are familiar with GitHub will recognize this workflow, and you can note how changes move around the system. You can see that there's the working copy in here. You make some changes to that working copy, make some writes, and then eventually compile it, sending that data out to Pandoc, make some fixes, lather, rinse, repeat until you're ready to commit your work. Commit, push up to GitHub, and then GitHub sends a webhook of some kind out to the continuous integration system. CI pulls it down, executes Pandoc, generally in a Docker container these days. Build artifacts and build errors end up going back to GitHub, where you can then act on them. It ends up being this really good system for asynchronous collaboration on a single document. That's what source code is ultimately. In this model, documents are simply source code. There are some Markdown specific text editors out there. I'm a big fan of Markdown. But all too often, I just come back to Vim with a few plugins installed for easily editing Markdown. There's one, I think it's called Goyo, that's like it'll put the text in the center of the screen and black out everything else. It's really good for focusing whenever you're creating some good documents. One of the main styles that I've adopted over time, realized this works really well, is to write 1 sentence per line. This makes it easier to suggest small changes to documents during the review process. GitHub allows you to make multi-line suggestions during review, but it's still sometimes better off to make 1 sentence changes rather than a paragraph change. When you limit the relevant content to a single file, you can definitely extract a single chapter or just a few chapters into a single PDF. This is great for a summary PDFs, like an executive summary of just the first chapter, or for testing only 1 file in a very large document. Our final paper, for which this system was originally designed, was approximately 45 pages, taking about 12 seconds to compile on my 2019 MacBook Pro. Compiling only 1 of the chapters took about 2 seconds. So you could really see where the speed up would come in there. Whenever you're committing, you want to use git commits to tell a story about the changes. That's the method established by a variety of experts on version control and pushed by one of my favorite people who speaks about version control, Stephen Ball, where he does a talk that he gave it. I saw it originally at Steel City Ruby in 2013. You can go find it on Vimeo, called Deliberate Git. And he goes on for a good time telling you and explaining, here's how to write a good Git commit message. Our team really took that to heart and really benefited from it. When you're reviewing code, you want to make sure that you are looking at prose, you're looking at grammar, spelling, whatnot. All of those things are super, super important. You're doing these things in pull requests. I do a whole talk on code review. I do a lot of code review, and both internal and external and open source projects. So I suggest doing some further reading or watching. You can find a video of me doing my my code review talk by simply searching Colin Dean code review in your favorite search engine. It's all over YouTube too. I highly recommend that whenever you're doing anything with pull requests, though, that you use a lot of automation. So GitHub has this code owners file that can automatically add reviewers. There's a few like GitHub bots out there that you can use to automate assignees and reviewers, and you can even like run Danger or Proselint as a bot. Those things are really, really valuable for saving time. Every time I've not set up CI on a repo using this template, someone has managed to merge to master something that breaks the PDF build, and it's been difficult to track down. I know what to look. I know what to look for now. One of the most notable things being that LaTeX doesn't like Greek letters inside formatting inside of equations, which is apparently a practice that was common a while ago when using older LaTeX engines, but LaTeX doesn't need it. So there are some people who are used to writing an older way of doing equations that is simply not necessary anymore. So it was difficult to track down, but we eventually tracked it down. Use GitHub's review system as it was intended to be used, and you'll be in good shape. Push the button when you're done. Discuss the suggestions. Write good comments. Be a good participant in discussing the code that is going in, discussing the document that's going in. This document was not without some pain. This process. Some things were easy to fix, others hard, and some are still unresolved, honestly. These are the big pain points that we had at first. Installing dependencies is always a problem. Even when we identified a Docker container that was adequate for our needs, then somebody has to go install Docker and then still has to download all the dependencies inside of a single Docker container. But that ended up streamlining things a good bit as opposed to our standard workflow of using a brew file with Homebrew. It does take a little bit of time to pick up on Pandoc's flavor of Markdown. It's basically standard Markdown, your common mark, but with a bunch of extensions on it, specifically around tables. How Pandoc handles tables out of the box is a little bit strange and counterintuitive to what people are used to using tables for when that table is going to be rendered to HTML. It just handles a bit differently whenever you're rendering to PDF through LaTeX. We did have some folks who were like, why can't I just use LaTeX? And like that, okay, that makes sense sometimes. But let's use something that everybody can use. And then there were some problems when people who were moving between Word and LaTeX, they wanted to write in something and then export to Markdown. That ended up proving problematic. And I'll talk a little bit more about that later. Some productivity pain points. There was an incomplete WYSIWYG story around this. We ended up falling back to this pattern of simply compiling a document and keeping it up in Apple Preview. Apple Preview would automatically reload the PDF. Some people would put it into like a browser tab and use something that would reload it in that. It varying levels of effectiveness with that. There were some bugs in the workflow as well, and I was the only developer who was actively working on this, so it was sometimes difficult to just get time to work on it. Lastly, the equation editing workflow was a little bit disjointed. you needed to use like an editor that already had tech equation support in it. But I almost always ended up falling back to LaTeX. LaTeX is a great little Mac OS program for just showing you what the equation is. And of course, you could just render it. That always was a good solution. We did have some other objections. Like somebody wanted to use something else, like I said, Word or LaTeX generally. Oftentimes it was LaTeX. One person wanted to use our Markdown to generate their Markdown file. And I said, you can do that, but only if you own that file. And that had some problems I'll talk about in a moment. It ended up just not really being a good thing. Because the greatest risk was overwriting. Transformation output overwriting other version files bit us pretty hard in a few cases. In subsequent use of this system, I'll talk about later, one person really strongly preferred to use LaTeX and another preferred to use our Markdown, as I said, and both wanted to convert Markdown to be versioned. This didn't go so well. I recommend doing this, avoiding this as much as possible. Store the original document in the repository and then allow the build system to handle the conversion from the original format, say LaTeX or R Markdown, to something that works with Pandoc. You can even just use the LaTeX and Pandoc will just include the LaTeX in the final output. And that's probably the most straightforward way to do things. Whereas R Markdown needs to be converted to Markdown by the R Markdown processor. That Pandoc doesn't have. But you don't have to take my word for it, of course. I offer solutions and like to get feedback on things before I go and tell the world, extol the virtues of my own work, because that's not so humble. One gent said, this leveled the playing field for contributions. It's great for collaborating and building documents with all of the features of LaTeX. But of course, that very same person did have a little bit of negative feedback that he missed having the fine level control of figures and subfigures and positioning. And these are concepts that that Pandoc doesn't really have. It doesn't allow you to say, put this figure on this particular page or wrap text around it in a certain way. It just kind of puts the figure wherever it most logically makes sense within the flow of the prose. Next, I'll talk about our current usage of this system after I take a drink. So we have growing adoption of the system. Our leadership was really impressed not only with the document that we produced, but also by our description of how we produced it. We've since expanded its use to other teams, including one fork of my original repo uses the basis for a documentation spanning several teams. Content is brought in through Git submodules, where each repository is also its own document. So think of it as like, I think 5 different smaller documents that get combined into one document. And it just so happens that the way that they're written makes both levels of the document work. It was a really cool way, a really cool system that we did for it. That ended up being 176 pages long with all of the diagrams and equations and code snippets and everything else. I think it was probably about 100 and maybe like 110 pages of actual written prose. The rest was all diagrams and whatnot. At least one person who was working on writing a book inquired about using this, which is pretty awesome considering that the basis of the system was actually what was used to write the first edition of A Friendly Introduction to Software Testing by Bill Laboon, a stalwart member of the Code and Supply community who self-published this book, and is now this book is now being used for a lot of college curriculums on software testing. There are many tools involved in the production of this system. Pandoc and LaTeX, Make and Git were the big ones. And then some other little ones I didn't really talk about that much. Proslint, librSVG was a fantastic SVG converter. MacTech is really like a distribution of tech and LaTeX that includes SayTech. And then I also tried some experiments with Tectonic. Tectonic is a tech engine written in Rust that can download LaTeX packages on the fly from the CTAN, the Comprehensive Tech Archive Network. It's like a package manager for LaTeX source. Didn't get super far with it because it didn't support some of the things that we needed in equations, but I'm looking forward to using it because it was super lightweight. The Tectonic was just like maybe 45 to 50 megabytes for the base installation, and it would only pull down what it needed, which was really only about another 150 megabytes worth of stuff, as compared to MacTech that's about 2 gigabytes. So where are we going with the future on this? Eventually, I'm going to make it write HTML output. My long-term vision is for us to have a single source document system that gets turned into a bunch of easily consumable formats, creating this searchable library of sorts, and turning it into like an internal archive.org, the arxiv.org for internal for scientific papers, and create essentially our own scientific paper search archive. And then, of course, there's style. Our documents use mostly out-of-the-box Pandoc and LaTeX styles with a few customizations. And I'd like to make that look prettier and more like our company. I'll probably leave Computer Modern as the font, though, because it just conveys a certain air of respectability and beautiful typesetting. So go check it out at pandoc.org. It has fantastic documentation. All the documentation is, of course, produced with Pandoc. I have spent a whole lot of time this year reading through the documentation, and I very rarely have I needed to go find other things. When I do need to find things that are not in the documentation, I've found Stack Overflow has a ton of Pandoc stuff, and that's all seemingly still relevant. Pandoc 2.0 came out 5 or 6 years ago now, and most of the questions are about the Pandoc 2.0. Some references and attributions as I close here. Use some icons from Font Awesome, and then, of course, referenced Bill Laboon's book. And you can, with the actual slides, you could go click on that repo link and go see the original basis for what I've written. I think it was written against like Pandoc like 2.3 or something like that. So I had to make some modifications whenever I used it. These slides, if you want to go check them out, are on my talks repository, github.com/colindean/talks, in the document workflow folder. My repository for all of my talks, source for everything that I do is there. And of course, then the rendered version is at speakerdeck.com/Colin Dean, and it's probably the most recent one. That's it. That's it for me. That's it for the presentation, at least. I can take some questions for a little bit. What questions might you have? I'll switch over to my Code and Supply camera. Give me 1 second. I have to do some weird things with OBS in order to get my camera out. So what questions might you have? Anything at all? Throw it in the chat, or you can feel free to unmute and ask.
Dean, hi. Sorry I missed most of the presentation. I was doing a neuroscience seminar several hours ago, and it's 7 a.m. for me, so you need to get fouled up. And you may have mentioned this, but I'm trying to put together a bunch of multimedia files. The core of the ones I'm working on right now are audio, and I'm putting transcriptions together, and I want to do links to the various documents and scholars that are referenced. This guy's been dead 30 years, so the author's not going to help me. What authoring tools do you think would be best for that sort of thing?
So Pandoc could help. I think if you were to write it up in some semblance of Markdown, either a format that maybe you were putting the information about each recording into some kind of a structured format, so like a YAML document or something, and then convert that to Markdown, then convert that Markdown to whatever eventual format you want. You'd get a lot of good typesetting infrastructure in place, regardless of how you're going to output it. This kind of thing sounds like you're probably going to build a website out of it, I assume.
Yeah.
Pandoc would be a good way to do that, especially because it would be able to include the bibliography, and you could include information in the BibTeX format bibliography that would allow people to more easily find that audio recording or somehow reference that audio recording.
Great, thanks. Do you know anybody at CMU? Because part of the team is there, but they are so busy, they're kind of leaving it up to me to do all the work.
I know many people at CMU, and if you contact me privately, I'd be happy to figure out what your need is and see if I know the right person to talk to.
Thank you.
Any other questions? All right. I'm not seeing anything else coming through. I'm going to give another quick moment to see if anybody's in the middle of typing something. There's been some occasions in the past where somebody's been like in the middle of typing and they're like, maybe while that's going on, I'll give another quick pitch for some code and supply stuff, especially our merch that I will probably always talk about because merch is cool. People like wearing our code and supply stuff, like stuff from abstractions and stuff from Artifacts that was a couple weeks ago, and you can see some cool stuff, get some cool stuff. Especially one of the things that I have really close here is a Artifacts hat. It's got our Heartsplosion logo on it. It's really warm. And then we also have a neck gaiter, which we learned just about the time we got these made that they're not necessarily good things for COVID-19 masks, but they're at least really warm. I wore mine around on a warm day and kind of regretted wearing it around on that warm day. All right, we do have a question from Alan Hauser. Did you have to do any author training, or were authors already familiar with the file formats? Some were familiar with Markdown very intimately. Most of the engineers really knew it very well. The data scientists were fairly comfortable in writing it. Most that had some exposure to it, but those who weren't accustomed to it, we very quickly brought them on board to it. A lot of times I'll just say like, oh, have you ever written a comment on Reddit or a comment on lobsters? Okay, well then you've used Markdown. Or I'll just say like, oh, it's like writing a README on GitHub, and then that tricks a memory that, oh yeah, so I've written this format before. And a follow-up question: what's the mechanism for defining the PDF formatting? Pandoc gives a lot of control through metadata to the rendering engine. So, for example, you could pass through things to include in the header. You could include any amount of LaTeX at certain points in the document, just as if you were writing a LaTeX document. It's kind of like a way to drop any LaTeX that you might need to do a custom thing. And this ends up a lot of times there's like a default template that Pandoc ships with, and really complex documents end up saying, well, just drop the template into a file and start making modifications to the LaTeX directly. That there's like a certain level at which you just almost have to end up dropping down to the LaTeX level in order to do things. PDFs to HTML. I don't think that I'm trying to remember if Pandoc actually can read PDF. I do know from a previous job that I worked at that extracting text from PDF is extraordinarily difficult because it is most things that would be able to do so are going to scan across, so they don't really pick up columns. If a document that has columns just is going to come out like just like a regular OCR. It's not actually OCR, so the characters are going to be correct as opposed to like OCR detecting an S as a C or something like that. It's going to be the actual correct letters, but it's going to scan across, and that might not get you what you want. I don't have a good recommendation on not proprietary tools for that. That was it. When I was at IBM, and we had access to a toolkit from Lexmark, which used to be an IBM company, or it was an IBM spinoff. I can't remember the name of it now. Tika, I think was the name of it. Tika converters. There may be an open source project around it, but I don't know the quality of it. I know we were using something internal. Any other questions? All right, seeing none, I think we're going to call it here. All right, so thank you very much for coming. My name is Colin Dean. I'm managing director of Code and Supply, and this was the rare occasion that I gave a talk for Code and Supply. So thank you very much for watching it, and I'll catch you next time. Bye. Go forth and do good.